There is a profound mystery buried just beneath the surface of the oldest farms on Earth. It is a secret that allows a single clay jar of water to sustain a lush garden for an entire week without a single drop being wasted to the wind or the sun. For 4,000 years, the most successful civilizations in history did not struggle with the daily labor of watering their crops. Yet today, we are told that modern gardening requires expensive plastic tubes, digital timers, and constant maintenance. We have been conditioned to believe that progress is measured in complexity. But what if the most efficient watering system ever devised was perfected before the invention of the wheel? Why was a technology that works better the longer you ignore it quietly removed from our textbooks in the middle of the 20th century? To understand why this ancient wisdom was suppressed, we have to look past the green leaves of the garden and into the cold economics of an industry that found a fatal flaw in a simple clay jar. The problem was not that the technology failed, but that it was simply too perfect to be profitable. We have to understand the journey of a forgotten tool that once turned deserts into empires, and why its return is the one thing the modern industrial world is not prepared for. The story begins 4,000 years ago in the arid landscapes of northern Africa and the ancient plains of Mesopotamia. In a world where water was more valuable than gold, survival depended on making every drop count. These early farmers discovered that the earth itself could act as a living filter. By burying unglazed earthen vessels near the roots of their plants, they created the first automated irrigation system in human history. This was not a primitive attempt at gardening. It was a sophisticated application of physics that we are only now beginning to quantify with modern sensors. From the Nile Valley to the hills of Persia, this method spread because it worked with the laws of nature rather than fighting against them. By the 1st century before the Common Era, this technology reached the heart of the Han Dynasty in China. It was documented in the first agricultural manual ever written, known as the Fan Shengzhi Shu. This ancient text did not just suggest using clay jars. It provided an exact blueprint for imperial food security. It described a system where a simple 6-liter vessel buried in a shallow pit could sustain a family through the harshest droughts. But why did this ancient success story vanish from our modern world? To understand this, we have to look at the massive shift that occurred in the 1960s. This was the era when modern drip irrigation emerged from research in Israel. It was a time of plastic revolution and high-tech promises. Drip irrigation was sold as the ultimate solution for efficiency, using a complex network of polyethylene tubes and precision emitters to deliver water to the base of plants. It was a marvel of engineering, but it carried a hidden price tag that the ancient clay jar never required. While the clay jar was a one-time investment made from the very earth it sat in, modern drip systems were designed for a world of recurring costs. These plastic lines degrade in the heat of the sun. The tiny emitters are constantly blocked by salt, sediment, and even small insects that find their way into the tubes. Animals like coyotes and rabbits often chew through the plastic lines, leading to a never-ending cycle of repairs. For a global industry valued at $7 billion in 2024, this fragility is not a bug. It is a business model. The suppression of the ancient way was not a loud conspiracy, but a quiet structural erasure. As agricultural universities began to focus on industrial-scale farming, the clay jar was reframed as a quaint relic for those who could not afford real technology. We were taught that professionals use microchips and pressure regulators, while only amateurs use clay. Yet, if we look at the pure physics of how these systems operate, the ancient jar reveals a biological intelligence that no modern machine can match. The heart of this system is a principle known as soil moisture tension. An unglazed clay pot is not a solid wall. At a microscopic level, it is a dense network of millions of tiny pores that act as a semi-permeable membrane. When you fill this jar with water and bury it in the ground, you are not just pouring water into the dirt. You are creating a hydraulic interface that responds to the actual thirst of the plant. This is where the magic of physics takes over. When the soil surrounding the jar is dry, it exerts a negative pressure, essentially acting as a vacuum that pulls water through the clay walls. As the soil reaches what scientists call field capacity, the tension drops and the seepage naturally slows down. If it rains and the ground becomes fully saturated, the jar stops releasing water entirely. It is a self-regulating system that operates on 0 volts and 0 human guesswork. It is the only irrigation method in the world that adapts to the size of the crop, the heat of the afternoon, and the humidity of the air without a single sensor or battery. The plant roots themselves quickly learn to embrace this source. If you were to dig up a jar at the end of a season, you would find a thick mat of roots wrapping tightly around the ceramic surface. They are not waiting for a timer to turn on. They are actively drinking from the stone. The efficiency of this forgotten method is staggering when compared to the systems we use today. Scientific trials conducted at the University of California, Riverside, and the University of Arizona have confirmed what ancient farmers knew by instinct. Buried clay pot irrigation achieves a water use efficiency that is 50 to 70% better than traditional surface watering. In sandy soils where water usually drains away too fast to be useful, the clay jar allows farmers to save up to 70% of their water resources. But the most shocking data comes from the developing world, where researchers are rediscovering these techniques to fight climate change. In Rwanda, a study on cabbage production found that using clay pots saved over 40% more water than a modern drip irrigation system. And wait until you see the data on the cabbage itself, which grew 32% more leaves and was significantly taller than the plants fed by high-tech plastic emitters. The benefits of the ancient jar extend far beyond simple water savings. One of the greatest enemies of any gardener is the weed. Weeds are opportunistic survivors that require moisture at the very top layer of the soil to germinate. When we water from above with a hose or a sprinkler, we are feeding the weeds just as much as we are feeding our vegetables. But the clay jar delivers water 6 to 12 inches underground, directly to the roots of the crop. This keeps the surface of the soil bone dry. In a study in India, researchers found that fields using traditional watering methods grew over 6,700 kilograms of weeds per hectare. In the plots using buried clay pots, that number dropped to only 23 kilograms. This is a reduction of over 99%. By using an ancient jar, the gardener effectively starves the weeds of the one thing they need to survive, eliminating hundreds of hours of back-breaking labor without a single drop of herbicide. There is another miracle hidden in the clay that addresses one of the most pressing crises in modern agriculture: salt. In many parts of the western United States and India, the only available irrigation water is saline or brackish. When this salty water is poured onto the surface, it evaporates and leaves behind a toxic crust that eventually kills the land. However, the unique physics of the buried jar creates a protective shield for the plant. Because the water moves through the clay wall via suction, the salts are naturally pushed away from the pot and toward the outer edge of the wetted zone. This creates a pocket of clean, low salinity soil directly surrounding the roots. Research by scientists like R.C. Mondal has shown that crops like cauliflower and eggplant can produce nearly full yields even when irrigated with water that is highly saline. In fact, in some trials, cauliflower weight was actually highest when using water with a salinity level of 12 decisiemens per meter, a level that would cause total failure in almost any other system. With a salinity level of 12 decisiemens per meter, it does not require a specialized supplier or a technical degree. It only requires a trip to a local garden center. The process begins with a standard unglazed terracotta pot. You must avoid anything with a glaze or a paint, as these coatings seal the pores and prevent the clay from breathing. Once you have your pot, the only modification needed is to plug the drainage hole at the bottom, A simple wine cork or a dab of food-grade silicone can turn a $10 pot into a high-performance irrigation engine. You then bury the pot up to its neck in your garden bed, making sure the soil is packed firmly against the clay walls to ensure the hydraulic tension can work its magic. Cover the opening with a saucer or a flat stone to stop the sun from stealing the moisture, and your job is done. A single 1-liter pot can provide enough water for a 2-foot circle of plants. Tomatoes, melons, and beans will find this hidden oasis within days, wrapping their roots around the jar to drink as needed. In the peak of the summer heat, you might only need to check the water level once a week. If the jar is full, you walk away. If it is low, you top it off. There is no risk of over-watering because the soil will never take more than it requires. If this story changed how you see the simple clay pot, help us preserve this wisdom by sharing it with others who want to remember what we forgot. Every like and every share preserves what they tried to erase.